Okay, so we're always hearing about getting humans to Mars, right? It's the big dream. This Space.com article dives into something that could actually make it happen. And not just getting there, but like doing it in half the time.
Yeah, absolutely. The article lays it out really well, the limitations of our current rocket tech. With chemical rockets, a Mars mission is, what, a multi-year commitment? Huge logistical hurdles, safety issues, the whole deal.
It's like, I don't know, trying to cross an ocean in a rowboat, right? You
Yeah.
better pack extra of everything. So how will we ditch the rowboat and get a speedboat to Mars? The article keeps mentioning nuclear thermal propulsion.
Exactly. And that's the key difference. Instead of burning fuel like traditional rockets, this technology uses, get this, nuclear fission.
Okay, hold on. I got to stop you right there. Nuclear fission. Like, we're talking splitting atoms to generate heat.
You got it. It's about splitting atoms to create massive amounts of heat, way more than you get with chemical reactions.
Okay, so help me wrap my head around this. What does that actually look like in an engine? It's not like there's a tiny nuclear reactor strapped to a rocket, is there?
Well, it's not that far off, actually. You have a reactor core where the fission takes place. And then that heat, it's used to superheat propellant, most likely hydrogen, which blasts out a nozzle to create thrust.
Gotcha. So the article talks about this being way more efficient than what we use now, but like, how much more efficient are we talking? Hit me with some
Oh,
numbers.
it's a significant leap. Nuclear fuel has vastly more energy than the same amount of chemical propellants. We could be talking about potentially 40 to 50% or more reduction in travel time to Mars.
Wow, okay. That's huge.
It's not even just about saving time, right? It means fewer resources needed for the trip, less radiation exposure for the astronauts, and a much lower overall risk for the entire mission.
That makes a ton of sense. But here's the thing. The article mentioned this isn't a new idea. This was being looked at decades ago. So what happened? Did we just forget about nuclear rockets for a while there?
Not exactly forget, there were actual test programs, especially in the US, back in the 50s, 60s, even into the 70s.
Yeah.
The big issue back then was the type of uranium they were using, highly enriched uranium, HEU.
And that was a problem because,
Well, I mean, aside from the obvious safety concerns of launching highly enriched uranium into space,
right, good point.
it also raised huge red flags about nuclear weapons proliferation.
Hmm.
Basically, using HEU in a rocket engine made it a lot easier for other countries to potentially develop nuclear weapons. It became a geopolitical issue on top of a technological one.
Ah, okay. So how do we get around that today? Because it sounds like we're making a comeback in terms of research into this tech.
That's where HALEU enters the picture, high assay, low-enriched uranium.
HALEU. It does have a nice ring to it, doesn't it? But seriously, why is this type of uranium any better?
Two big reasons. First, it's way safer. HAU is much less likely to cause an uncontrolled chain reaction, so it's inherently more stable than HAU. And while it's still powerful stuff, the lower enrichment level makes it much less useful for anyone trying to, develop weapons.
So problem solved, right. We can all breathe a sigh of relief, and we'll be sipping, I don't know, HAU lattes on Mars in no time.
Well, not quite. There's a trade-off. HAU is safer, sure, but because it's less potent, you need more of it to get the same amount of thrust, which of course translates to a heavier rocket.
Okay, yeah, that makes sense. So how do scientists and engineers get around that?
Well, that's one of the most exciting parts of this whole thing. They're looking at new materials for the reactor core itself, things like ceramic composites that can handle those incredibly high temperatures and pressures. And they're also refining the engine designs, trying to squeeze every ounce of efficiency out of that HAU fuel.
So it's like you're trying to design a race car engine, right? But it has to be super powerful and lightweight at the same time. And you need those crazy strong materials to handle all the heat and pressure.
Exactly. And we haven't even talked about the actual conditions these engines would face during a mission. Think about it. Startup and shutdown alone put huge stress on a reactor, any
Oh,
reactor.
right, of course.
And then you've got the insane temperature swings going from the cold vacuum of space to, well, the intense heat of operation.
Hmm.
So I wonder if these things even work at all.
Seriously, it sounds like they have to be like practically indestructible. How do you even test something like that? You can't just like build a nuclear rocket engine in your backyard.
That's where things get really wild. Remember how the article mentioned scientists are using like advanced computer models to simulate all these crazy conditions?
Yeah, yeah. So what does that actually look like?
Well, they basically create these insanely detailed virtual models of the engine.
Hmm.
And they subject those models to every possible thing they could think of.
Hmm.
Extreme temperatures, vibrations, radiation exposure, you name it, they throw it at it.
Wow.
And all of that generates just mountains of data, right?
Yeah.
And that data helps engineers figure out, okay, where are the potential weak points? Where could this thing fail?
So it's like what? Putting the engine through its paces in a virtual crash test
Yeah.
before you even build the real thing.
Exactly. And these simulations,
Hmm.
they're getting more and more sophisticated all the time because computing power keeps increasing. So we're talking about a level of precision and predictive modeling that, honestly, we couldn't even have dreamed of just a few years ago.
That's amazing. And speaking of real-world testing, this is where the DARPA program comes in, right? Like the article mentioned, NASA wants to launch an actual, for-real, nuclear-powered rocket by 2027.
It does seem crazy soon when you say it like that.
Yeah.
But yeah, 2027. DARPA, it stands for Demonstration Rocket for Agile Cislunar Operations.
Right.
I know, right? But anyway, it's a huge deal because it's a big step in proving this technology can work, not just, on paper, but in the actual brutal environment of space.
Okay. So this is more of a demonstration mission, not a full-on trip to Mars or anything. What are like the main goals of DIOCO?
Right. So it's not going to Mars. It's really about gathering crucial data.
Yeah.
How well does the engine actually perform? How's the thermal management working? Is the whole system stable and reliable? It's about taking those computer models we were just talking about and, well, actually seeing if they hold up in the real world.
So basically proving that nuclear thermal propulsion is a real viable option if we want to get serious about deep space missions.
Exactly.
This feels huge, honestly, like kind of a turning point for space exploration. If this DARPA mission is successful, what are the bigger implications down the line? Are we talking regular trips to Mars? What about going even further?
Those are the million-dollar questions, right? But the potential is definitely there. I mean, if nuclear thermal propulsion lives up to even half the hype, it could revolutionize how we explore the solar system. I mean, it's that big of a
Yeah.
deal.
Okay, so let's say DARPA launches, everything goes perfectly.
Yeah.
What happens next? What does the future of space exploration look like with this technology?
Well, first off, Mars starts to look like a much more realistic destination, right? Instead of these multi-year missions with all the risks and logistics nightmares, we could be talking about reaching Mars in a matter of months. That opens up so many doors, more frequent missions, actual scientific outposts, maybe even someday human settlements.
Wow, okay, that escalated quickly. But it's not just about Mars, is it? What about those really far off places in the solar system? The ones we've only seen through telescopes, like those icy moons around Jupiter and Saturn.
Yeah.
The ones that might have whole oceans beneath the surface.
Exactly. Those become much more interesting targets with this tech, right? With nuclear thermal propulsion, we could be sending robotic probes, maybe even crewed missions, to those distant places in a fraction of the time it takes now. I mean, imagine collecting samples, studying those alien oceans, maybe even searching for signs of life. It's incredible.
I know, right? It's mind-blowing. But, okay, let's come back down to Earth for a sec. This all sounds amazing, but realistically, what kind of timeline are we looking at here? If DARPA is the first step, how long until we're sending probes to Jupiter's moons or building those Martian outposts?
That's the big question. And honestly, it's tough to say for sure. I mean, space exploration, it's full of surprises, setbacks, things you just can't predict. But if this Draco mission is a success, and if there's enough continued investment in this technology, I think we could see missions to the outer solar system within a few decades.
A
Easily.
few decades? That's actually sooner than I would have thought.
Ah,
Makes you wonder what those missions will find.
doesn't it?
Yeah.
It really makes you think. And, it's not just about the cool scientific discoveries either. This tech could have huge implications for humanity, back here on Earth too.
Oh, how so?
Well, think about if we can travel through space faster and more efficiently, it opens up all kinds of possibilities. We could start talking about resource extraction, maybe from asteroids or other celestial bodies. Imagine accessing rare Earth elements or other resources that are getting harder to find on Earth, right from space.
So it's not just about exploring, it's about solving problems, maybe even some of the biggest ones we're facing here at home.
Exactly. Now, obviously, there are a lot of ethical and logistical things to figure out, but still, the potential benefits, it's huge. You can't deny that.
It's like opening a door to this whole new chapter for humanity, Exciting, a little bit daunting, and definitely something we'll be following closely right here on the Deep Dive.
Couldn't agree more. It's
Yep.
a story that's still being written, but I have a feeling it's one that'll capture our imaginations for a long, long time.
I think you're right about that. Well said. And that just about wraps up our deep dive into the incredible world of nuclear-powered space travel. Hopefully, you're as excited about the possibilities as we are, from cutting those Mars travel times in half to maybe even unlocking new resources and pushing the boundaries of exploration. This technology has the potential to change everything. Until next time, keep looking up.